me see if there's any chat messages here. Okay, hello, hi, good afternoon, everybody. So this is good. And okay, so I can take over now, Anandji. Yes, you're there. Can you hear me?
He left. I don't see him online
Okay,
anymore.
okay, that's fine. That's fine. That's okay. I just wasn't sure with that, but you can hear me. Yes, so I think that's good. Yes, I just want to see if I can share my screen. I can share my screen. That is also good. We'll start. So give me a minute or two. So can you just let everybody know inside when they come? Yes, because I think that it asks me to enter them one by one. I hope it doesn't do that when I start this sharing of the screen. Okay, so welcome everybody. Good afternoon, and we're going to obviously we are recording. And hi everybody. Yes, so we'll start exactly at 3 o'clock as per our plan, and we will continue for the next 3 hours, of which the last 1 hour will be the coding as we did last time. And unfortunately, I don't know how to do this. Is there a way in which we can admit everybody or something? Because once I start presenting, I don't see these. I don't see people who would want to join. Uh, okay, let me see how this works. Anyway. Okay, so what I'm going to do now is that today we're going to continue with where we started off. And again, like I said, we will do this quite slowly. So we'll keep repeating some ideas again, just because everybody can kind of emphasize them. And also as we go along, we will sort of cross relate them back. And today I will again sort of change the mode a little bit, give you some more examples and so on before we go into code in the last 1 hour with Aisha. So the point here is that one of the only things we asked you to do last time was to make sure that you can at least get into Colab so that you can run some code. So this will be the idea, so that you are able to do that. And then as long as you continue to do that, I think this will be good. So now can you check Priyanjan, can you admit people? Do you see people? Can you try and admit him?
No, I cannot. I don't have that access. He
You
has to
don't
make.
have the access.
Uh,
I'm
I
afraid.
can
Okay.
ask. I can ask Anand if he can give it to me.
Yeah. You also make you as well, so that the point is that because when people come here, if I start presenting the screen, I actually don't see them because it's in full screen, and they'll be just waiting out there. So people are still joining. Here we go. Yes. So I still need to make sure that I have them all inside here. Okay. Okay, so the point here is that we will revise some ideas, we will start some new things, and we will continue to sort of develop this. But again, like I said, over the first 3 weeks or so, we will do 3 or 4 weeks, we'll do one notebook, and then we'll go back and do the second notebook. And there are, I think, totally 3 notebooks we will do over the 8 weeks with that. But we will repeat these notebooks a few times with the code going forward. So Premchand, did you hear from Anandji or?
No, he did not reply. I will call him. Just give me. I will be on mute and I'll call him.
Yeah, sure, yeah. Let me see if I can make you one. Hold on a minute. Maybe I can make you. Maybe I can make you the host. How do I do this? Uh, no, I don't know how to do this. I can't. Ah, there is Anand. Yeah, there is Anand. Hi, Anand. Hello. Hi.
I click. right click on the parted element.
Yeah, because otherwise if I start presenting, then they would not be able to, whoever is coming in would have to wait with it. So we haven't started yet. I'm going to start in a minute. I just want to be sure that I hand over the host to somebody else. Otherwise people will be not admitted once they come in the session with that. Very good. So now I'm going to start sharing. Yeah,
Priyaranjan is
very
our
good.
host now. Is it
Yes,
okay,
Yes,
Priyaranjan?
yes.
very good, very good. So this way he can admit it. Thank you very much. So that people as they join, they can admit it, because once I see the full screen, I won't be able to see who's waiting to be admitted. Very good. Thank you, Ananji. Very good. Okay, good. So now I'm going to start with where we started last time. And I will, okay. So last time we started off with this format here, and I will do a quick recap today, because recap is important. Repeating an idea is important because it will anchor you to the concepts with that, and also the fact that we will sort of go with some of these ideas going forward. So we'll follow the same format as usual. We'll do a couple of hours of sort of discussions, and then the last 1 hour of coding with Aisha. And for that, the only thing we asked you last time was to make sure that you can get into Colab and try some of the notebooks. Some of you have tried that, but again, that you don't have to complete everything as long as you are able to run code. That's what we are trying to get you to do. And once you have that, that's good. So, okay. Now we were going to start off, quickly recap what we did last time, and then we'll go proceed forward to the next stage. Yes. And today I will sort of give you more examples which will anchor your thinking to machine learning and deep learning, because examples are quite important for you to understand how something gets applied. And the more you see things in practice, the better you're able to see that. Okay. So what we did last time was we started off, I'll go skip over all this stuff. Yes, because we don't need this. We started off with the idea that basically what is machine learning, what is deep learning, what is narrow AI, what is general AI. So basically we said that the idea of machine learning is explicitly training an algorithm, learning from the data. The idea of deep learning, we said that learning automatic feature detection, which meant that you learn the structure of the data and the meaning of the data as well, which is different from machine learning, because in machine learning you explicitly you tell the features, and therefore you tell the structure of the data. The deep learning algorithms learn the structure of the data and the meaning of the data. So this is the meaning of that. Artificial intelligence is the term which can generally use to say the machines that can think and reason, and most of those algorithms currently are based on deep learning algorithms. The word narrow AI is what we see today, which is practically AI applied to a specific problem, whether it is healthcare or cybersecurity or any such thing like that. General AI is something which you don't see today, but it is more like the Terminator movie, which means that you have AI which is capable of operating under any situation. So rather an algorithm which can operate in multiple situations. The closest thing we come to that today is GPT-3, which was the big algorithm, which has a lot of controversy around it at the moment. Okay, so far so good. That's the basic definitions. Then we talked about this. So we talked about this general flow of supervised learning, which said that you have labeled data from which you get build a model, and then you show it data which it had not seen before, and it is supposed to make a prediction. A prediction being the general word here of either classification or regression or something like that. So this is the general flow of any supervised algorithm. Of course, this does not include unsupervised algorithms. It does not include the more complex algorithms like deep learning and stuff like that. But the general flow is the same. General flow is that you learn from labeled data. That is called supervised learning. It's called supervised because it is labeled. Yes, so this is the general flow with that. Then we talked about the idea of deep learning. We said that the deep learning works like the human brain. The idea of actually any brain, the idea of deep learning is that you basically train the algorithm through a neural network. A neural network is modeled on the working of the brain, but it is modeled into layers of neurons, artificial neurons, which are sort of stacked into layers as we see here, and it is trained by an algorithm called backpropagation and gradient descent, which we haven't discussed so far, but that's good. It is trained through a series of data objects such as images of cats, of dogs, of stuff like that, and then you then infer based on that, meaning that you effectively show it something which it has not seen before, and then it is able to categorize that as something, for example, a dog or something like that. Of course, this is more serious than cats and dogs because it can apply to tumors, it can apply to genomic sequences and stuff like that. So in that sense, it's a very generic algorithm within there. Then we talked about this structure where we said that when you build a neural network, what you do is build these connections between neural networks, correct? So in the middle section here, you had this green thing here, which effectively um, said that you have a structure where the neuron connections are made, and that becomes a model, a trained model, and then you deploy the model and we show it a picture for the first time, such as a cat. It flows through this image and then identifies these sort of networks within that connections, and it is able to build this relationship to the cat. So it is able to say that when the neural network is trained to identify a specific pattern, it can do so. This is the general theory behind this. Then we talked about machine learning, deep learning, and things like this. And again, I'll skip this section here because we don't need all of this. This was more generic discussion. This one is important because we talked about what type of problems use machine learning or deep learning, and these are the problems where you have a large problem, you have an open-ended problem. It's a hard problem. It has hidden rules. It has hierarchical rules. It has one or more variants around the core, which means that you have a dog. You have a concept of a dog, but the dog concept can have many variants. Like I said, it can be an Alsatian, a Doberman, a Wolfhound, a Chihuahua, or whatever. So this is the concept, that a concept that a particular idea around it has many variants. The problem could be generative meaning that we talked about some of that before, that you don't necessarily need to just sort of discriminate some data set. You can generate copies of that, and the best example of these deep fakes which you see using AI. So this is the general structure within that. Then this example was important where we said what is the difference between your traditional programming and machine learning. Traditional programming takes in data and the rules and gives you the outcomes, and machine learning takes the data and the outcomes and gives you rules. So the whole point of machine learning is that it is a type of a system where where you are programming it to find meaning behind something. Yes, you are not specifying the meaning behind something. So in traditional programming, you specify the meaning behind something. You have an if then else statement, you have a for loop or whatever loops you have, and then you say that this is the structure, this is my code, this is my logic, and from that logic I get an outcome, correct? But in a machine learning sense is the opposite, because you provide it many samples from which it learns a pattern, and from that pattern it finds some rules and then applies those rules to a problem which has not seen before, correct? So I gave you the analogy of driving a car, and I said to you that if you're driving a car, if you're learning a car on a particular, learning to drive on a particular road, then the idea is that you have learned enough about the principles of driving so that you can go to any road and apply that knowledge to that situation, correct? So this is the point. This is what you're attempting to do. The same idea here, that you're attempting to learn the rules of something based on some examples. Once you learn those examples, you can apply them in another context which you have not seen before. This is generally the sort of idea where we are going to with that. And then I talked to you about this idea which you talked about, the flow of data science. What do? You obtain your data, you clean your data, you do exploration, you find out a basic hypotheses behind your data using a number of techniques which you will use in code, histograms, dimensionality reduction, clustering, etc. And then you build a model. A model is basically a combination of algorithm and data, and then you interpret the results of the data where it is seen, and you say what the accuracy is, and so on and so forth. So this is the general flow of a data science problem. Yes, and this is sort of depicted in that same example there before. Now we go a little bit deeper into that. We talk about labeled test training sets and test data sets. A training set is you take your data, you split it into training set and a test set. You use the training set to train the algorithm, you use the test set to test it, how the model works, and therefore you are able to effectively build something with which you have some level of trust. And no machine learning algorithm is 100% accurate, so you always have an accuracy or some metric to say that this is how good my algorithm is, or not how good my algorithm is, and that's a general idea within that. Then there is a whole bigger structure around machine learning, because then there is a whole mathematical structure in the computer science structure. So the mathematical structure is based on all these things such as linear algebra, Monte Carlo, Bayesian, stuff like that, most of which you don't need to worry about it at this point. Then there is a computer science structure, because you can build it using big data, you can build it using columnar databases, you can have different programming languages, and so on and so forth. So this is another bit of it, which again does not directly connect you. And then you have different data formats, which are images, video, text, time series, audio, etc., etc. And you have modalities, meaning that you have the cloud, the edge, DevOps, and so on and so forth within that. Then we talked about what is machine learning. We looked at explicitly training an algorithm. Then we talked about a formal definition of machine learning. Then we talked about what it means. These are the different examples: the classification, regression, attribute importance, anomaly detection, clustering, and so on. So these are all of these things which you have covered last time. And again, these are classic machine learning problems. And initially, we'll spend a lot of time on the first two, classification and regression, because 90% of the work you will do, if you're working in a traditional job for machine learning or the data scientists, will be in those categories. And then we'll spend a little bit more within that. Of course, we'll spend machine learning and deep learning. Yes, so you can do classification using deep learning as well. And this is why we have 3 or 4 notebooks which will cover that, and the code which you already have. So we'll run a specific set of things. We'll go back to it again. I know some of you asked the question, even with the pandas data set, why exactly are we doing this? But again, I just want to get you guys familiarized with certain ideas. Same as Aisha presented about that, because all this stuff is you need to implement it in code, correct? And this is the whole point, that's what a data scientist does. So you need to sort of get in there and do and build it. So this is why you need to know both the theory, the maths, and the building within that. Then we talked about this idea of the learning within machine learning. And I sort of told you that think about it as what you learned in your maths, as the equation of a straight line. Then I said that the idea of machine learning is that you can learn an algorithm which is of which you don't know the pattern behind it. So you don't know the equation behind it. So in the left hand side, the equation of a straight line is y equals to mx plus c, which is practically what you would remember from your high school days. On the right hand side, this shape does not have a discernible equation behind it. However, with a deep learning algorithm, given enough examples of this pattern, you can find the hidden function fx, knowing x. So this is the whole point of deep learning and the power of deep learning, that you can find out effectively a mapping between your two domains. And this is what makes deep learning so powerful within that. And you can think about it as a hidden function or a black box, or however you call it within that, but it does able to sort of give you a particular pattern within that. Okay, so at this point, I will take some questions. I know we haven't really started yet because we are still recapping what we have done last time. I'll also put my video off. We don't need the video on here. So I will take some questions now. There are 47 of us, which is great. So there's quite a few of us already again. So I was never sure how many people are going to be sort of continuing with us right to the end. But like I said, if you persist with this, you will definitely learn something from this. Okay, so we haven't even started today's what I wanted to do, but I've run it about 15 minutes so far. And we did a revision of what we are doing. I haven't even finished that revision yet, but let us take some questions. If you want to ask something, you can post it either in the chat or you can speak, and I will respond to your questions now. Okay, good. So any questions on this so far? You can either post something or you can speak. Yeah, I'll give you a couple of minutes. Yeah. No?
So,
Yeah.
hi, this is Pushpa here.
Hello. Hi.
Uh, so the question that I have is basically when we start with any of this machine learning model, and
Yeah.
uh, is it good to define a use case and then think about like how are we going to apply it? Because a lot of times it happens that it does get a bit overwhelming. Very honestly, I mean there are a lot of things that are there. So what would be the best way of starting? Should we like define a small use case and then say that, okay, how are we going to employ machine learning algorithms or whatever that we want to build, and then look at how it gives an output?
Sure. So today I'm going to spend a lot of time giving you examples of places where you use specific algorithms. Yes. So I will go through that into multiple ways today. So hopefully, I don't even know whether I'll finish it today or not, but that's a good question, and hopefully you will see it today. With that, to the end of today, you may be actually knowing a little bit more about this than what you did before. So that is my sort of first observation in that regard. The second observation is that what you said is the sort of example use cases is generally you will get it from experience, meaning that if you think about this 80-20 rule, yes, so if you think about that, the majority of the problems are solved by very few things. So if you look at it today, if you look at Kaggle competitions, or if you look at most of the banks and so on and so forth, you use one or two types of algorithms, XGBoost, for example, which is highly used in Kaggle competitions. Um, Similarly, if you are using, if you have image data, then you use some form of deep learning algorithm if you want to find something from that. So the short answer is that you learn from your experience. The long answer is that you would kind of the longer answer to your question is that what people really do, and which we will do as well, is you build a baseline and you try to improve the baseline with other algorithms. So this is generally the approach which people do. So nobody can really say that this classifier is better than the other. So people sort of try it out. They try one thing and they try to improve it within other things. uh, but you'll sort of get this answer as you go along. Is that okay? Yeah.
Yeah, that's perfect. Thank you so
Perfect.
much.
Thank you very much. Okay. So then this next question is from John. Would you call anomaly detection a particular type of classification? No, and I'll tell you why, John. So anomaly detection is the detection of outliers. Yeah. And outliers are examples where are things which do not fit into a particular pattern. Now, a classification is the slide deck. So sorry, I'm just distracted by the question from Farid. So Farid, the slide deck is the same one I was using last time. It is on Slack, so I didn't send it again because the same one from before. I'm not doing anything new. I'm continuing with the current one. There is something new which I will have to upload, which I should have uploaded now, but I will upload it in the chat here with that. So I'm still going by the previous deck because we haven't finished it. Sorry. Okay. So coming back to John's question. So classification is when you're typically training using a data and categorizing it into labels, either a two class or multi-class, correct? So you're trying if you do multi-class classification, then you are labeling it between maybe if you had 10 digits, yes, so then it's a 0 to 9, so you have 10 classes as your classification. Yes. If you're doing if you're two class classification, then it is a yes or a no, maybe a spam or a no spam kind of stuff. But an anomaly detection is a different problem, and the reason why it's different is to do with the fact that anomaly detection actually is cannot be used using traditional classifiers. And the reason is because there are very few cases of anomalies. And this means that, for example, if you have fraudulent transactions, yes, if you have 1,000 transactions, there are two which are fraudulent, something like that. Yes. So what then happens is if you were trying to train it using your fraudulent transactions, you'd only have two to train with, which doesn't make much sense. So what you then do is you do use unsupervised learning. So you train it with a good case, meaning um, the non-fraudulent transactions, and then you find the distance vector between your new case and your good case. So for example, if I train it using my 990 good examples, then I have an unsupervised learning algorithm which shows good cases. But when I show it the bad one, if it says that the distance metric between the bad one and the good one is large, then I know that this is an anomaly. And in that sense, anomaly is a different type of a problem. I would not call it a classification problem. I hope that answers your question, John, as best as I can. Okay, any more questions?
I had a question.
Yeah,
Yeah, so since we spoke about deep learning and stuff, I was
yeah.
just curious to know, are we also going to discuss about transformers for natural language processing or something like that later during the course?
I would say no, no, because I know that very well. I know your question very well, and we have a lot of experience at Transformers. In fact, this week in Oxford we have GPT-3, so we are running a full GPT-3 session. I have used that type of thing as well. But I think with this group and the level of a level of knowledge we have here, I think that is too much to do. At even in the 8 weeks. So my strategy in the 8 weeks is that I'm going to try and make sure that all of you get to the point of a certain standard where you can solve these problems. Yes, when I say solve these problems, you can solve a typical machine learning classification, regression machine learning classification, and a deep learning algorithm with a traditional algorithm with multi-layer perceptrons, and a deep learning algorithm with images like convolution neural network. This is my general sort of goal I'm going towards. So, and I think that that would take me at least 8 weeks with this group. I think which is a diverse thing. So for that reason, I will not be covering that. If you have an interest on this, I will share with you something more separately. You can,
Sure, yeah. Looking forward to another invite like this in the future, or
yeah,
maybe some materials like that. Because I remember having worked on BERT and distal BERT and things like that. So if some theory could be, clarified from you, that would be really great in my career.
yeah. It depends on what you want to do with it. I mean, are you building it, or are you trying to understand what it is?
Yeah, I've used that in my projects, but then I would just want to understand a bit more on that because I know there's a book called as Transformers by Rothman, and that book is
Mm-hmm.
so complicated. I mean, for beginners. So if someone like you, could just shed some light on, some basics, just like you've done it beautifully for the earlier concepts, that I thought would be really great.
Yeah, I think it's Dennis Rothman. No, that's the guy in
Yeah,
front.
that's
Yeah,
it.
yeah, yeah, yeah,
Yes,
yeah.
yeah.
I actually, yeah, he's a
Well,
friend.
he assumes. Oh, okay, that's
Yeah,
great
I
to
know
know.
him. I know him personally quite well. He's
Okay,
connected to me on LinkedIn as well.
got it.
I think that book. Yeah, you're right. It does
He
go
assumes
into.
a basic understanding, so
Yeah,
it's not good to start reading that book straight away. So I
yeah,
just
yeah,
thought if
yeah, yeah,
you could shed some
yeah,
light on that,
yeah,
that would be great.
yeah. Okay, but yes, maybe if you have time. Yes, okay, good.
Mhm.
Thank you very much. Yeah.
Sure. Thanks, Ajit. Yeah.
Yeah, thanks. Any more questions on this so far? Again, we'll take it slow. We'll take it. We'll
Mm.
as answer as many questions as possible. Sorry.
Yeah.
Yes. Yeah.
Hello, sir. Yeah, actually, last week you gave one example about the Google Maps. So it is like evolving and machine learning. But my question is, Google Maps gets evolved by the feedback of the user. So how it is different from machine learning or AI and the manual inputs? Means how it is evolving itself.
So Google Maps is an example of something which is an algorithm and data. It is evolving based on usage, and any machine learning algorithm evolves on usage. The more you use it, the better it is. So for example, if you look at Google Maps as an example, the more we use Google Maps, the more we tell Google about a particular thing. At the least, it is telling you that 100 people are going on this particular road. Yes, so at least that is something that is usage within that. If there are shops nearby, it tells you more. If you tag some locations, it tells you more, etc., etc. So every time you give some quote unquote metadata to the algorithm, it learns better and faster, and this continues until it becomes until it evolves from that point onwards. Now the algorithm itself could also change. Of course, Google could change the meaning of how it interprets, but we never see that. So we don't see the workings of those algorithms. But I mean that the more data you feed an algorithm, the more it learns, and it learns because it is machine learning, because it is just traditional data which is fed to that. So this is what I meant with that. Cool. Okay. Thanks. Yeah.
Okay, thanks.
Thanks. Yeah. So any more questions on this so far before I go into the thing?
Ajit, sir, just one thing. I
Yeah.
mean, if I have forgotten, please excuse me. Have you shared the like 8 weeks agenda?
No, I have not actually.
Oh,
I have purposely not done that. There was an agenda which was published by Anand before, but
uh-huh.
I purposely want to see the sort of the nature of the group, and before we go that, we will actually share with you the agenda hopefully by next week, because I think I will have a good idea by next week. So I'm already saying, even with the previous question, that we are going to do four key things. We are going to do machine learning, classification regression, and we are going to do deep learning algorithm, the core algorithm, and then we are going to do deep learning with images. So this is the general structure, because 90% of the problems you're going to face in a traditional job would be in those groups, basically,
Oh,
within
thank you.
that. Cool.
Thank you.
Thanks. Yeah. Good. Any more questions now? Okay.
I have a
Yeah. Sorry.
request. Previously, somebody asked about transformers, and I've also used Distilbert for my NLP sentiment analysis. So, if you are sharing that material with him, could you also please share it with me? My name is Sonal.
Okay. Sure. Yeah, no worries.
Thank you.
Yeah. Okay. Thank you. Yeah. Okay, so I'll go back now to my slides. I will start sharing again, and we do this with that. Okay, okay, okay. So we were here at this point, and we are showing the current slide. Okay, good. So what we are saying here is that we are effectively the whole point of machine learning or deep learning is built on statistical foundations, which is effectively what is mathematical modeling, meaning that you have a real world problem, you create a mathematical model of the real world problem from which you infer something. And with machine learning, you just sort of take this to the next level. And with deep learning, you take it to a more deeper level, and you add computer science on it, and you add other things on it. And this is how you get the current AI field. Yes. So this is why the AI field is a little bit complicated, because it is built on this history of already complicated things. That is why people keep saying that you need to know maths before you learn AI, which is true and not, because you can get away without knowing lots of detail of maths. However, for certain jobs, the sort of work I do, you definitely need to know what's behind it. So this is the philosophy, but generally that's why AI generally goes with that. So then we looked at this idea of prompt algorithms. We had a very brief overview of algorithms. We talked about supervised learning, which is training from examples. We talked about unsupervised learning, which is sort of learning from sort of clustering and things like this. Then we talked about anomaly detection, which is like fraud detection and so on. Then I talked about semi-supervised learning, which is examples of generative models or semi-supervised learning. Then I talked about how you can categorize algorithms by similarity. By similarity means you can do regression algorithms, which is what we are going to do today. So this is the first type of algorithm. Many of the stock market examples and so on and so forth, they use regression. They try to find out a value based on history. So regression basically tries to fit a line or a curve between a set of points, and this is what you end up with it. Then there is a classification, which is support vector machines, logistic regression, etc. Classification tries to separate something into two or more categories, and then you have a new data point. You try to say which category the new data point belongs to. Yeah. Then you have these things like instance-based algorithms, which have k nearest neighbors. Then you have regularization, which we will come to afterwards within there. Then you have decision tree algorithms, which is effectively a simple structure which basically tries to categorize into different categories. Then you have Bayesian algorithms, which are the Bayes theorem within that. Then you have clustering, which is again trying to find clumps or clusters between things and try to satisfy what they are. K means, and then you have association rules. When you have dimensionality reduction, which is something where, again, we will talk about this later on. Now, this is just a sort of a high level view of things. Then you have ensemble, the French word ensemble, which means that you combine different things. You combine weak classifiers to get a longer, better prediction. They're called bootstrapping and boosting. And then you have the sort of, that's where we sort of look into that. And then the key terminology with machine learning algorithms was that you start off with effectively a simple data set which looks like something like this, which has a number of features, which is what defines the problem. And then you have a target variable, which in this case, the median value of the house. This is a Boston housing data set, which shows you the median value of the house is what you're trying to predict based on certain features, which include the size of the rooms, the age of the property, the proximity to good schools, that type of stuff. Yes, so these are the features which constitute or which impact the target variable, which is the price, and this is what you end up doing with it, and this is how you build that. You can do the same sort of thing with salary, where you have histories of salaries, developers in New York, and you see what their salary is, and then you are able to do the features which make that. So for example, if you're in New York City, obviously you get paid much more, that type of stuff within there. So, and then you have some other things such as hyperparameters and so on and so forth, but we will come back to those into a bit more detail with that. So again, the sort of idea is the same, that you train something in a supervised manner and you make a prediction on something which you have not seen before. So I keep repeating these ideas together because very soon you're going to see them in code, and that's what's going to happen. And that's why you need to understand what is happening before you sort of end up doing that. Now I go a little bit more deeper into this idea, where you say that you have label data, you have training data, you have a test data, you have a learning algorithm, you have evaluation, and then you sort of do certain things such as sort of you do model selection, cross-validation, performance metrics, hyperparameter optimization, etc. And then you sort of tune it using all of these factors of algorithms, which is the iterative process. I also added this thing on the left top corner here, which talks about feature extraction, feature selection, dimensionality reduction, and sampling. So that's what happens before the algorithm sees the data. So before the algorithm sees the data, you do certain feature engineering to the data, which is again what you will see in the code. You have to change certain things, you have to combine certain things, you have to provide missing values, you have to make sure that all the values make sense, you have to remove the anomalies, you have to sample the data, sometimes you have to reduce the dimensionality of the data. All of these things happen before it hits the algorithm. Before it hits the model. So these steps are very iterative. So you have the sort of the feature engineering, then you have the model building, and then you have the model evaluation, and then you do these things back and again until you come to a point where you are reasonably happy with the result of the algorithm. That's the whole point of it. And then we talked about deep learning algorithms. Deep learning algorithms are basically modeled on the brain. They look like this. And you would immediately say that no brain looks like this. You've seen pictures of the brain, and they don't look like this. But in a neural network, this is what we do, because this is a computationally feasible model. Meaning that if you had every neuron connected to every other neuron, you would never be able to model it using mathematics and computer science, because that the whole point is that you want to build a structure which you can use, correct? So that is why this structure is a simplification. So what you do is that rather than saying every neuron connects to every other neuron, like in the brain, you say that you put these neurons in layers, and neurons in each layer connect to the previous neuron, that type of stuff. So this is what I mean by simplification. But the idea is the same. You provide inputs, you have hidden neurons, and you provide an output, and those are trained as it trains. Like we see the picture here before, if you remember this, like these ones in the middle, what you're seeing here has got much deeper connections, because at this point it has been trained. So the green lines are thicker and more prominent. On the left hand side, you didn't have any green lines because it is untrained algorithm. You showed it lots of examples of cats in this case, and therefore it was trained to recognize a cat. And the way it did that was form the connections between neurons, just like the brain does. Yes, and then you show it a picture of a cat for the first time, and it was able to run that picture through those connections in the brain, and I was able to say that this is a cat. So this is the idea of a deep learning neural network, which we saw before. There's some other examples of deep learning neural networks, which we won't go into at the moment. And then the idea of deep learning is all about finding rules. and you have problems for which rules are not easy to find. And those type of problems, as I said to you, are what are called non-finite domain problems. So a finite domain problem is a problem like chess, where the rules are relatively easy to define for a computer, that is, because you have effectively a finite domain. The world is finite. Yes, the world of chess is finite because you have 8 by 8 squares. Every square moves in a predictable way, that type of stuff, correct? But on the right hand side, the world of what constitutes a dog is practically infinite because there are too many variants around the core concept. We talked about this before, and this is the sort of problem typically used by so deep learning is suited for. And what you do there, what you do effectively is you do bottom up. So you work from the bottom up. You have these neural networks. The lowest layer finds one thing, it feeds to the next higher level, and it continues to do so until you build up a structure from the bottom of the neurons to higher up within that. And this is what you do at the higher levels. You are able to sort of extract these features, and that's what you end up doing within that. So this is the philosophy of the deep learning algorithms, which learn bottom up. So the bottom layers learn the sort of the pixels, the ones higher learn the edges, the ones higher learn the contours, and then you have the sort of the higher levels making out certain features. So for example, you can say that the highest, this layer would basically constitute maybe the headset, the headband of the woman, or the head or the goggles of the woman, that type of stuff. So if every layer builds up something at the highest level, you are able to say what this is or not. And this algorithm keeps being trained by neural networks within that. This is why you see pictures like this in deep learning neural networks, because the left hand side is more corresponding to the things at the bottom where you don't have too much structure. But by the time you're coming here to the right hand image, it's like coming to the higher levels here, at which you are able to discern faces of people, correct? So this is what is happening. This is what I mean by bottom up. In the middle layer, you are seeing these sort of hodgepodge things which look like things which could make up a face but could not, like eyes and stuff like that. So this is what happens when you build up something bottom up. You find out the higher levels gain levels of abstraction such that you are able to sort of understand what something is. And then this brings us back to the more deeper example I talked to you before. So this is what I was trying to say, that the sort of the AI portion builds up on other things and then kind of goes from there with that. And of course, none of this is trivial. So this is all about not the cats and dogs. It's about tumors and genomic sequences. And this is why AI is such a powerful and sweeping thing, because it impacts so many areas within that. Mathematically, if anybody is interested, this is the chain rule. If you remember this from your maths, I won't go into any other maths here. With Oxford, I do far more maths than here. But effectively, this is a function within a function. If you remember, this is the chain rule. And then you do effectively yeah, if you find out the derivative of a function, of a nested function using the chain rule. And that's really what it is in the end of the day, because you have one at the highest level is a classifier, and within you have nested function. Each layer of a neural network is effectively a nested function, and that's why you have function out wk dot function out wk minus 1, and so on and so forth. So you keep nesting a function inside a function, and then you find a derivative of the function using the chain rule. That's really very simple maths behind it, relatively speaking. Yeah. And then you can go along, and then there are a number of examples where you use AI, which we didn't discuss last time. They include things like gesture recognition, biometrics, machine vision, computer video surveillance, handwriting recognition, text recognition, entity recognition, natural language processing, movement prediction, creating images from text, sentiment analysis, etc. And what is common about this is none of them are based on traditional tabular data, correct? So they are based on things such as sentiments, image, text, sound, audio, video, that type of stuff. And that's really the power of deep learning with AI. Then there are two specific algorithms which are relating to deep learning, and they are called, one is reinforcement learning. Reinforcement learning is a very powerful algorithm currently being used by Google to do all sorts of amazing things. If you saw the news last week, they talked about the reinforcement learning algorithm effectively using being able to sort of model the working of nuclear fusion and making the nuclear fusion breakthroughs which you saw in the UK much more better within that. So this is the sort of power of an algorithm called reinforcement learning, which effectively learns by trial and error. So we won't go into that, but just to let you know the landscape within that. Then you have some notes with this. And then there is something called GANs, Generative Adversarial Networks. This again is in the news mainly because of fake images, but it is much more than that. It has far more uses behind this, some of which we will talk about, but it gets a lot of news for this fake images type of thing within that. And the way GANs work is it's like example of a cops and robbers. So it is a generative algorithm as opposed to discriminative algorithm, meaning that you from sample random noise, it generates fake images and it tries to compare that with real images until such time that the real and the fake are the same, at which point it is able to create good fakes. Basically, this is the basic idea behind the GAN. And the GAN, of course, is again not a topic we are going to cover into detail in code. When I say detail, I mean in code. We're going to spend a lot of time in code looking at machine learning and deep learning algorithms, and that is classification, regression, and then my MLP and CNN. So this is the general idea of what we are going to try and do over 8 weeks. But I'm just going to give you, I was trying to give you a big picture of what's out there with AI within this sort of complicated. And some people asked about the example of transformers, which is another big thing at the moment, which is getting a lot of traction within that. Here I described what is the GAN. Again, I won't go into detail with this, but the same idea within that. And what are the types of AI problems? Effectively, I can sort of classify AI problems into these categories. Again, it helps you to think about AI problems because I'm going to spend a bit more time today explaining problems and algorithms before I hand over to Aisha for code, which will be at around at 5 o'clock. So I will, by the way, we will have a break again as usual. So maybe we'll have a break in another 15 minutes for another 10 minutes or so. So after 15 minutes, we'll have a break depending on how many questions you have. It's very sort of flexible. So types of problems. The first problem is what is called a domain expert, meaning that AI can learn to simulate the behavior of an expert. The best example is people worry about, will AI replace my doctor? Not likely, but AI could replace a lawyer, which people have normally no problems thinking about. But the reason is because AI can replace a function if it has enough examples of it. So in the legal case, there are many examples of cases, as you will see, which an algorithm can be trained on. But it is not the same with traditional healthcare, with some exceptions. And those exceptions are to do with, for example, cataract or radiology or something like that, where you have lots of label data for something. So that sort of thing is possible. Second one is domain extension. Domain extension meaning that it learns a complex body of knowledge and generates more information based on that. So the best example of that is drug discovery. So drug discovery is something where you learn a pattern based on data, and then it identifies new combinations of that. So for example, I worked in a company which effectively takes protein databases and tries to produce a combination of those databases so that then it is able to produce new drugs. But the validity of those drugs, of course, is a different example because it takes a very long time to actually test something to be real or not. But AI is good at creating combinations from existing things. So this is what I mean by domain extension. Then you have complex planning. This is much like the operations research, which we learned in high school. However, in this case, the difference is that AI can look at very large number of patterns, and that means it can do far more than traditional humans can. Then communications, which is more like intelligent agent, chatbots, and things like this. New perception. So new perception is in things such as tasks which require a lot of AI capability, such as autonomous vehicles. So this is an example of new perception. Digital transformation is the general term I use for all sorts of changes in the enterprise, which can happen as a result of that. Then you have the whole enterprise AI, which means a whole bunch of cognitive capabilities to the enterprise. Again, lots of examples of these where you are applying some sort of AI to the function. Then there are examples of second order consequences, for example, insurance. So you can predict insurance based on your healthcare. There are already some services in the UK which talk about this idea, where you are able to, if you wear a device, for example, then they are able to give you a better insurance deal or something like that. So that type of what I mean second order consequences. And finally, two examples which are problems in the near future that could benefit from improved algorithms. This is not really a category, but I would like to include this because I think that there are some examples which will be better over time. So for example, language translation was one such thing. So when the first time language translation was started, people almost laughed at it, thinking that translators will never be redundant. Today, everybody uses Google Translate and it works perfectly well. Yes, so well, in most cases. So I think that that's because algorithm has improved over the last 10 years, 15 years, due to changes in the algorithm itself and also changes in the data. So this is what I mean by something which doesn't work today. Don't just give it up thinking that it's not going to ever happen. In 5 or 10 years, it would possibly end up replacing jobs in that category. And final category, super long sequences. Super long sequences is, I got this from the head of Google, Uber, when ex-head of Uber, I used to know him at that time. And this is a problem which involves a long sequence of things. For example, genomics is one thing. Uber rides are also sequences because you have a time series which is a very large time series, and you want to use it to make a prediction or something like this. Okay, good. So this finishes the first part of what I wanted to share with you, and obviously there is more. So I'm going to stop sharing now. I'm going to go back and I'm going to take some questions now. So, okay. So we have, let's take some questions again from what I have covered so far, and then we will take a 15-minute break after that. Then I will continue until 4 o'clock when Aisha will take over. Aisha is possibly not yet here yet, so I think that Aisha will join us at 5 o'clock. Okay, so any questions now so far?
Oh, hi, sir. This
Yeah.
is here. So I'm referring to this seventh use case or seventh problem type, yeah, enterprise AI addict.
Uh-huh.
The problem that I'm facing today is I work in a sort of a B2B business. Yeah. So compared to B2C, which is business to consumer, where a huge amount of data is generated and it's easy to train,
Mm-hmm.
let's say, chatbot. But
Mm-hmm.
in case of B2B business, uh, and the customer queries are very bespoke for their account, for their contract, for their discount, and it feels like a human intervention is required there to solve that specific problem. So there is a dilemma, whether to spend time and effort in the automation or let the human continue. So you might have come across such situations as well. So any thoughts?
Yeah, so I think that first thing what you said is a very general statement, so that B2C has more data and B2B has less data,
Mm-hmm.
which is sort of true, but not always. So for example, if you think about call centers, yes, if you think of call centers, so every time the call center says that this data, your call may be used for training and quality purposes, yes,
Mm-hmm.
you hear this all the time, but they don't tell you training and quality of who. It could be that
Mm-hmm.
you could be training and quality of your AI. Yes, so it may not be for the training and quality of people at all. My point is that organizations, especially large organizations, collect
Mm-hmm.
a lot of data. People who are in supply chain, people who are into any of those things collect a lot of data.
Mm-hmm.
So the first thing is that they do have data. The
Okay.
second thing is that the data and the problem are related. So what you want to do with the problem is relating to the data. So for example, I talked to you that I worked in this genomics bio industry, yes, or
Mhm.
cybersecurity, yes. You have exactly, I had a condition where a particular healthcare problem was there, and we have exactly 30 people, old people who have this condition, and they were in an old people's home. We had the data with that, extremely secure data, very hard to get, but only data from 30 samples. Okay, they had for one person, you had more samples. When some of them died, and they said that they want to take away the data out from there because the family felt that they wanted to maintain the data. So the point at that point is you start to do far more statistical things, but it is possible to do. So the less
Mhm.
data you have, the more complicated or complex algorithms you can write. So where I mentioned to you GANs, generative adversarial networks, for example, we have a problem where we use GANs to generate data, yes, to generate more data for training. So we
Okay.
understand the distribution of a data set, then we use the GAN to generate data which is not fake data, but it is similar data, and then when we sort of train the algorithm within that. So there are many ways to cover that. So AI is a very complicated field, especially at the more sort of complex levels of it. So there are all these techniques which people use. So that's what you would do. My kind of answer with that. Cool.
Okay.
Okay. So Shaurya has raised her hand, and Farid has raised his hand. So I will take as many questions as we can, and then we'll take a break. So I'm not fussed about running off in 5 minutes. Let's complete the questions. So Shaurya, yeah.
So basically, sir, I've got this question that if I give some sets to some data sets to a computer about translations about different languages,
Uh-huh.
okay, and I speak a different language that is not on the data,
Mhm.
will it be able to recognize the language or not?
So the short answer is no, it will not be able to recognize it. The long answer is there are these more complicated and recent algorithms which are able to learn very generally from things. And they do this by understanding the sort of, so for example, there is a paper which talked about how you can find out extinct languages. You can understand extinct languages. Yes, so languages which are no longer spoken by people, correct? And the way you do that is find out the patterns or similarities between current languages, and you try to find out things which are related to old things. So, for example, Aramaic, which is the language of Jesus, yes, so that is not a real language anymore. However, there is, well, it is, but only I believe 100 people or something like that. But there are similar languages from which you can derive that language. This is what I mean. But the short answer is no. I hope
Okay,
that answers your question. Yeah.
thank you.
Cool. Okay. So Ashwini has posted, and Farid, you have raised a hand. I'll come back to you. Ashwini, the chat here. With the historical data used in deep learning, there is a lot of talk around bias in AI. What needs to tackle that? What is your opinion on that? Yes, this is the big problem. Bias is a huge problem, and bias is relating to data. So there are a number of ways to tackle bias. There, I can share with you some papers with that. Um, the best one I have seen, I don't know if you're in the UK or not, Alan Turing Institute, they have a very good paper on this. Um, the the way people handle this is that you have to first of all provide it data which is real, meaning that which represents more range of people as opposed to a particular group of people. Therefore, the data is important. The second part is the explainability. This is very important because this is where a lot of techniques are possible, which means that you are able to explain the result of an algorithm, because the more explainable it is, more transparent it is, which is the way to handle that. So there are two ways to handle that, either from the data or from the algorithm, and that's the general way to do that. But I can share you a specific thing with that if you're interested into that. Okay, so Farid, yes, please.
So if you go back to your example of bottom-up
Yeah. Uh-huh.
facial recognition,
Yeah.
What's the difference between what you're proposing there and the traditional if-then-else rule-based method?
Okay, so there are three levels of complexity. Yes, the first level is when you are able to provide the rules for a given problem. Correct. This is when you have the if then else is the sort of is a way of talking about a rule. Yes. So
Mhm.
if I am able to say that I have all possible rules for a situation, then I'm able to codify those rules. Now the problem is, of course, you do not know all possible rules for something. So for example, I have a fraud detection problem, and today a fraud detection is such that people are ordering something. So there is I am selling iPhones, yes, on the thing on the web or on a call center. So somebody calls up and says that I want 5 iPhones delivered to me on Monday morning at 10 o'clock into some domain. Yes, so this is probably a fraudulent transaction. It depends on the area or the postcode. So these patterns may differ, or tomorrow they might have another new scheme for doing that. So the point is that the more you learn from data, the better it is. So there are three levels. The first one is you absolutely codify all the rules. The second one is you learn the rules from the data, which is machine learning. And the third one is you learn the rules and the structure from the data, which is deep learning. So the typical case is that if you actually have the rules for a particular problem and those rules never change, then you can absolutely codify them and you won't need an algorithm at all. In fact, there are gray areas behind these. So there are some algorithms which take some learning or what is called expert knowledge or human intelligence, and they incorporate that into that algorithm. In fact, this last week on Oxford, if you look at my LinkedIn, I shared about a particular technique of sort of what is called machine teaching, which is exactly that. So you are able to then teach a machine using some human knowledge. But those are the three categories. So that's your question, Farid. The lowest level is that the lowest level is when you know all the rules and you can codify all the rules and the rules do not change. And the highest level is that you don't know all the rules, you don't know the structure, and the AI learns everything. And then there are things in the middle.
But where you don't know the rules, or you don't know all the rules, you must start surely from some subset of rules to which you add.
No, you start off from the data. You start off from the data and you learn the structure from the data. So if you start off if you start off from Boston, if you look at the housing prices, yes, you start off with if you start off with 1,000 transactions, which are labeled. So you said that this house was sold in 1990. It was costing $100,000. It had this number of 3 bedrooms, that type of stuff. So you give it data, and you give it an example. You give it a target, and then you kind of make those rules from the data. So you do not start with a pre-configured rule.
So sorry to labor the point, but if I understand correctly, then for example, in your facial recognition example, you would give lowest level data, labeled lowest level data, and proceed up the tree until you can identify the face. And then once you have enough data and constructed enough rules from that data, then you're in a position to test your algorithm with data you haven't seen before, and then verify that those rules are correct. Is that
Correct.
correct?
Yes,
Okay.
yes, that's right. That's the correct understanding. Thank you. Yeah.
Okay, thank
Good,
you.
good, perfect. Yeah. So again, we'll take some more questions. I think I've spoken to everybody who's raised their hand. I'll go back to the chat. There are some more questions here. Let me just scroll up to see I'm not missing anybody here. Okay, there are a few questions here. Okay, so Ridwanullah, yes, from a typical AI problems you mentioned, sir, it seems the most industrial AI problems solved with a customized model, and not popular AI models such as. So industrial AI problems are quite a different situation, mainly because they don't have enough data. Well, they do have data for certain cases. So for example, a classic industrial problem is what is called the sort of predicting the failure of a machine. Yes. So there you have enough data. but you don't have enough data to design a new propeller, for example. Yes. So this is where you sort of have a spectrum of possibilities. So if you have data to model that, you can do that. Or if you have a complicated process for which you have partial data, you can partially model it, but not completely. This was the previous example I was talking to about. If you see my LinkedIn post, the last one I made last night from Ken Sanderson and things like that, where he talked about this sort of architecture. So if I had, for example, a chemical plant, and the chemical plant, I'm trying to understand the behavior of the chemical process, and it has got some very high thousands of degrees of something, and the best way people understand this process is they look at, if you look at the light, and they're able to understand how hot it is or something like that. There are certain rules which are not easy to build using data because you don't have enough examples of it, and that time you have to use other techniques. But in general, the popular AI models, I would not call GANs and transformers as popular AI models because they are still very new. So typical popular AI models are the ones we are going to learn in this course, which is multi-layer perceptrons, MLP, and which is the classic deep learning architecture, and the convolution neural networks, which is image-based architecture. And then you have the typical machine learning techniques in the deep learning, machine learning classification, machine learning regression. So those are the popular AI models, and those are across the board. You can use them for a range of things, assuming you have enough data. So I hope that answers your question, Ridwan. Okay, so Sonal, what is the difference between the reinforcement learning and agent-based modeling? That is a very good question. Short answer is agent-based modeling is so reinforcement learning, since you're asking me the question, reinforcement learning is a classic sequence-based problem with a Markov decision, with an MDP, Markov model, hidden Markov model. So the sequence-based problem. An agent-based model may not be sequence-based. It may have other things. So the techniques for using agent-based modeling are some form of graph deep learning neural networks. Again, it's a complex question, so I'm telling you the answer in a way in which I hope you can understand it, but it is not something which I have spoken about before, but I hope that answers your question. So the first one is an MDP, Markov decision process. The second one is probably some sort of graph-based architecture, agent-based model. So Ridwan, again, 1 minute. From your explanation, domain knowledge and experience very essential model development. So it depends, Ridwan. So domain knowledge and experience is useful in certain cases when you do not have enough data. And that's always a spectrum between that. So the early days of AI talked about a lot of domain knowledge. Today, they talk about less domain knowledge and more data. And I think the future will be a mixture of both. So I think that this is the spectrum with a moving goalpost, so to speak. And yes, so domain knowledge is obviously useful. There are techniques or ways in which you incorporate domain knowledge. The best one which I can think of, is most popular, is Bayesian learning. Bayes theory. The Bayes theorem basically says that the more you know about something, the more sure you are about something. So for example, I say to you that I went today to the train, I was in the underground, I met my friend. So this is one statement I have made. The second statement, I say, I met my friend and my friend had long blonde hair. So, okay, it knows that I have met a woman, for example. Yes. So the more statements I have, or more propositions I have, the more it learns about a situation, the more sure it is about a particular possibility. So that's the way people put domain knowledge into a problem. So this is Ridwan's question. I hope that best answers your question, but there are of course other ways. Bayesian is the most common within that. So reinforcement learning, so this is Raj. Reinforcement learning is an area of machine learning concerned with how intelligent agents ought to take action. Okay, this is fine. Like reinforcement learning, one of the three basic machine learning paradigm. Yeah, this is fine. Good, thank you. Yes, so Raj, you are just stating that, and yes, I agree with that. So Shaurya, does search engine use deep learning? Search engines use, typically Google uses something called PageRank, which is not a deep learning algorithm, which is basically a graph a database, basically, if you want to classify it as something. However, Google is talking about replacing PageRank, and in fact, I'm going to blog about it this weekend, or because one of my students asked me in Oxford, I will share this with you as well. So the short answer is that Google is planning to replace, well, there is a theory that they could replace it by the more of these BERT or transformer based models within that. There's a paper which talks about that. So Raj, machine learning is used in almost every part of the stack. Google being anything that requires some sort of intelligence is often used machine learning. Okay, find your search engines to help. Okay, thank you, Raj. Thank you, Ridwan. Thank you, Raj. Shaurya, thank you with that. Okay, good. Okay, Philippine, thank you, Philippine. Thank you very much. Okay. Very good. Okay, good. I think we've answered all the questions as best as I can. We'll take a 15-minute break now, then we'll come back and we'll go into more examples and more kind of questions. But then again, I always spend time with questions because I think this is what I said to you before, that the questions will be the most interesting thing in this one, because this knowledge, you will not get it from anywhere else. The sort of thing that I'm just telling you randomly, just from my experience, that's the bit which you will never get anywhere else, because the rest of the stuff you possibly can if you search it. Okay, we'd go for 15 minutes and then we are back in about 20, it's about, yeah, 15-20 minutes, yeah, 15 minutes from now. Okay, all right, we see each other in 15 minutes. Thanks. Hello, everybody. Welcome back. So I now shared with you the slides which I'm going to use now. I also posted them on Slack, and I also noticed that Ashish posted the code, and also Saif has posted about the Alan Turing Institute. Thank you, Saif, for that. The one which I just mentioned. Although I'll post another report, I think, from them on the explainable AI, which we were using from there. So cool. So yeah, Saif, yeah, please go ahead. Yeah. You have a question?
No, actually, I raised my hand in accident. Thank you. Carry on, Ajit.
Oh,
Thank
no,
you very
no
much.
worries, no worries. Yeah. Okay, yeah, sure, yeah. Okay, so I think that that's good. So what I'm going to do now is share these slides here, and we go on until 4 o'clock when Asha will take over with the code. And this will be quite light now because I think this will be quite a few examples which will hopefully anchor your thinking to how AI works, and that is another good way to sort of learn things in addition to the code with that. So the slides which I'm going to share with you now are the ones which I shared on the chat, and also the one which I shared on the Slack. So I will wait a minute. Okay. Okay. So again, I don't know how much of this I'll be able to complete now, but it doesn't matter, and we'll continue on next time around, and we'll continue on from there as we go along with that. So this is the format we will use: is that the first bit will be the concepts, then will be the code. Sometimes the concepts will be, of course, ahead of the code, and as much as we can, we will try to keep the two in sync. But that may not always be the case. So okay, so I will share the window. Okay, so now what we're going to talk about here is we're going to talk about examples of using algorithms. Yes, and sometimes it helps you very much to sort of understand how AI works based on stories and examples. And when you see enough of them, you begin to understand a particular pattern in the usage of AI. And this is the objective here. The first one is a news article which talked about people confuse computer generated music with the work of Bach. Yes. And the reason for this is because if you think about this is a generative algorithm, meaning that it has learned, it's a GAN, some kind of GAN, which has learned the music of Bach based on the pattern. It has learned the distribution behind that, and it has then learned to create effectively fake examples of music which sounds like Bach. Yes, and the reason why it's able to do that is because it has got lots of examples of music from Bach. So for example, if there was an algorithm which learned to play music like me, this would not be possible unless it repeatedly sees music I play, if I can play music, and then it sort of learns from that. So the point being that if there is enough examples in the public domain about a particular data set, be it something like music or audio or things like that, that pattern can be learned. And once that pattern is learned, you can generate similar examples of that. And that is what this is saying here. People confuse the music of Bach from computer generated music, which sounds like Bach. And the way that has happened is because it has learned from samples of that music. Okay. A similar thing happens with pictures. So AI can paint like Rembrandt or something like that, or Monet or something like that, and partly because it can learn a particular pattern of a painting and then create variants around that, and so you can see that the sort of the night sky from Rembrandt has been modified into other pictures which look like that. So this is the example of that sort of thing within there. The same thing can happen with your handwriting. So so the thing which will be sort of anything which has been there, but this is something which one of those teachers tried to say, is that if you sort of copy or write things, AI can learn that handwriting very easily, for the same reason that it can learn a particular pattern based on behavior, and it can mimic that pattern within that. Another very enterprising young student from UCL, I believe, although this wasn't stated here, was able to write a chatbot which overturned 160,000 parking tickets in under 2 years. And the way he did that was because parking tickets are labeled data. Yes. So if you are parking at a particular point, and if you have got a ticket for that, you are fined for that. And more importantly, the way he managed to subsequently do that was effectively look at court cases, which then looked at the judgment from the judge and look at how the appeals, which appeals succeeded, and then he was able to craft your appeal based on appeals which were succeeded, and therefore you could overturn these parking tickets just by using an app. Well, the app is just an interface, but the AI behind it has learned from 160 lots of parking tickets in history and appeals for those parking tickets, so that it was then able to craft your appeal if you so needed it, so that you could overcome your parking ticket from there. This one again is a very famous one, which AI could create fake footage of Obama having said something which he has never said. And that again is possible because there is lots of images of Obama in the public domain, and therefore you can just literally crawl that, copy that, and use that to train AI, in this case another GAN, generative adversarial network, and it is able to then create fake examples of Obama speaking when he hasn't said something within that. Of course you can make him say things like that. So this is what this one is about. Doodling. The same pattern happens because people doodle in a unique way. They sort of scribble in a unique way, and AI can learn that pattern and doodle like you. And by now you should be able to sort of understand that this is a classic example of learning what is called mathematically distribution behind a problem, and then try to mimic that distribution mathematically. So once it's able to do that, then it can do all these sort of things very well. Same happens with the screenplay. So in fact, this weekend we have a GPT-3 example at Oxford, which is by a liberal arts student, liberal arts teacher and his students, and they are using AI to create stories. So they're using AI as a collaborator, so that there is three of them trying to write a cast for a Netflix, for example, and AI is a participant in the conversation, trying to create these characters and trying to create these stories and so on and so forth. So all of these things are now possible because AI is able to learn lots of history, lots of data, and is able to create or effectively generate or spit out something which is based very similar to what it has learned. And that's the beauty of that. Then you have an AI program, that a Japanese AI program that wrote a novel which almost won literary prize. Again, the same idea, which you managed to do. By the way, these are all links. These are real links, as you can see, and they're a few years old now. So I believe that more things have happened since then, but it's a good kind of a use case to talk about things. This one's very interesting. This one talks about AI can predict how long your relationship will last. And the way that works is that if you go to a traditional relationship counselor, for example, if you and your partner go to the counselor, and then you talk to this person about something. Yes, you talk about how good or bad they are, or your other person is, and so on and so forth. But the way AI would learn this is very different. So AI would learn something on what is effectively the sentiment or the modality behind that. So for example, if I say the words "I love you" to somebody, AI can detect, given enough examples of "I love you" from people who are in love or not, that to say that this "I love you" is not really a real one, meaning that your real emotion behind it is not reflected in your in your expression, and therefore it is able to successfully predict better than humans, um, how, when I say humans, I mean a trained counselor, whether your relationship will last or not. And that's basically based on that idea. A Robotic Kitchen, this is something at a London company, which basically learns by observing. And this is another very big sort of research area with AI. So it can cook based on observing a chef. So it learns to understand how the chef cooks, and then learns to take the same ingredient from the same place and add the same thing without it being explicitly taught how to cook something. um, these sort of things are extremely interesting, and when I say this, many of my friends, especially female friends, would say that you could, for example, not copy Jamie Oliver, because Jamie Oliver is so expressive that you couldn't, an AI couldn't see that behavior and copy that. And I possibly would agree with that. But my point is that it is possible for AI to learn things just by observation. It can definitely learn how to cook of giving enough in observing enough people how they cook with something. And certainly simple things like bricklaying have been very easy for AI to learn already. If it's simple repetitive task, just by observation it can learn it and then can copy the task with that. This one is a cucumber farmer in Japan who used AI to sort cucumbers. The reason is, in Japanese cuisine or even sushi and stuff like that, the quality of the cucumber matters a lot. Therefore, what you have is the ability or the desire to sort a very accurate cucumber from other ones. And this is a convolution neural network problem, because what you do is you have AI which has learned by images of good cucumbers and bad cucumbers, and it's able to sort this out. This was done a long time ago with fish as well. So if you are on a trawler and you sort of catch a whole group of fish, it can sort fish out visually, because it is trained to understand the fish visually, basically. So this is the point about it. Now, obviously, pneumonia, that's very important, because again, it's a convolution neural network problem, because it is able to see images of people who have pneumonia, and it's able to say how to classify them. Skin cancers, same situation. It is able to see people who have skin cancers, like see images of tumors, and able to classify them from there. Cataract, same thing. It is able to see images of cataract and able to sort of diagnose them better than ophthalmologists. Yes, this one is interesting. This AI at software at JP Morgan did in seconds what lawyers could do took 360,000 hours of work. And this had to do something with some kind of a legal case, financial deals. And the reason why AI was able to do that was because it had a long history of those transactions. The moment it had them, it was able to learn them and was able to do what lawyers did within seconds, because it was a trained algorithm. So this is what I mean by suddenly things change so dramatically from the ability to learn from data, that you can perform many of these tasks purely by kind of learning from them. This one is an interesting one. This is Associated Press, which uses AI as a reporter. What that means is that it effectively is able to write a story about something without ever sending a reporter there. Now, this sounds like replacing jobs at news stations, which it does, which it is, but it also is an advantage. So it can report on stories in smaller towns and smaller cities or smaller clubs where you cannot afford to send a reporter, but at least AI can write a story which is very similar to that of a reporter. So this is how it works. Human rights trials. AI predicts the examples of human are very similar to the parking ticket example, where AI was able to predict the examples of human rights trials based on the same idea, basically with that. This one is a concierge robot, which is able to kind of welcome people with that. Uh, Again, a combination of convolutional neural networks, voice recognition, chatbot technology, and so on. So multiple things have come together to make something like this, but it is autonomous. This is the point. It is not pre-trained, meaning that it is able to understand a conversation and make a conversation with you autonomously with that. The Hadron Collider largely was very high sort of contribution of AI, partly because it's a very a problem with a very large domain because it has got many combinations, 600 million per second, and therefore human beings cannot do that, and AI can do that quite well. Obviously, the CIA has been using AI to predict social unrest, and other countries have been as well. Lip reading is possible using AI. So AI can effectively do lip reading and can understand what something is said within that. AI can pick up a single voice out of a crowd. Again, same idea, that is able to train a particular voice and recognize that. This one's a bit creepy. So this woman created an AI of her dead boyfriend, and this she was able to do because she had lots of data about her boyfriend, text messages, social media conversations, that type of stuff. So she trained something which effectively now speaks as if it were her boyfriend who is dead. Creepy, but I'm giving you examples of sort of how this would work within that. AI can recognize gait. Gait means how people walk. AI can recognize that. Very similar example. What I'm trying to tell you is this is a video, and it works in the same way, because the video is nothing but a sequence of frames. Yes, and once you know that, then the same thing applies basically. Okay, good. Now we'll take some questions on this, because I think this is a good time to I can stop sharing. Can I? Okay, I can stop sharing.
Ajit.
Okay. Yes.
Hi, Ajit. Yeah, I had a question. So you showed the deep fake about Obama in one of these
Hmm.
slides, right? So
Yeah.
deep fakes, as you said, they work on generative adversarial networks.
Hmm.
And basically, I was curious to know, is there a way to detect if a video is genuine or is that a deep fake? Because that poses a grave threat to the security of a person and in general to the security of the world, right? So is there a way to detect that if a video is deep fake or not? Is there an algorithm to do that or something like that?
No, in fact, the deepfakes are getting so better that there was a news article last week which said that people trust a fake face more than the real one. So there isn't a really good way to do that, because it is just an image. There is some AI being written to test whether something is fake or not, because you can test whether something is fake by looking at very small levels of changes in the human face, which human beings cannot see, but AI can. You can possibly do that, but the short answer is, and not the answer which you possibly wanted to hear, is that the defects are getting better, and they're getting harder to detect. So yeah, unfortunately, no. So that okay.
Okay.
So Philippines questions. Philippines. Yes. Do you happen to have any suggestion for AI? Uh, Sorry, you need to mute yourself, I think, possibly, because some reason it's echoing with
Yeah,
that.
yeah, hi. Yeah, the question is that I have some colleagues who are doing research on sign language,
Mhm.
and they are trying to they're looking for software that can identify sign language, which means it needs to recognize, it has to do facial recognition and something with the hands,
Right.
because those two things are important. And I thought maybe you happen to know something.
No, but I think it is not a problem which is unknown, meaning that you can definitely do it based on what I just said with all these things.
Yeah, I would
Cool.
think so.
Yeah.
Yeah.
Okay. Cool. Thanks. Yeah.
Thanks.
Okay. Good. So next question is from Shreya Desai. Yeah.
Sir, so number of example you have told us.
Yeah.
So in that case, I mean, what could be the best algorithm? How can we identify, or is there any method to approach such problems?
No, I mean, this is where you need the experience to do that. But so in some cases, many of them examples I gave you are generative. So the moment they are generative, you know that it is not. So there are two broad categories. Yes, so generative means that it is generating data, generating example, discriminative, meaning that it is classifying or categorizing examples. So the generative ones are mostly GANs. The image based ones like the cucumber are convolution neural networks. Many of the sequence based ones are, for example, stock market ones. For example, if I were to use that, then they are basically some form of regression or time series or things like that. So the short answer is that I'm going to continue on with some more examples, just immediately following, depends on how much time we have with that. But the short answer is it depends partly on your experience with it. But most people after a while will be able to learn it. Yeah, cool. Okay, all right. So Dr. Gore, yes.
Yeah, thanks, Ajit sir. I had a quick question. So, for example, in medicine, we do differentiate with the benign condition and malignant condition.
Mhm.
One which is not cancerous, one which is cancerous. So, AI algorithm will develop rules, and if we then with the obviously with independent case, then AI may be able to tell us whether this is likely cancer or not.
Yeah.
But what I wanted to ask is, there will be lots of evolvement as well in the clinical cases.
Yeah.
So, can we subject this algorithm for unsupervised learning? So it will learn with the new cases as well to get better and better every day.
So to learn with new cases, you don't need unsupervised learning. To learn with new cases, you just need more supervised learning, meaning that you have more cases, you feed the algorithm with those new cases, and it will have learned from them. So the unsupervised learning is when you are doing things like clustering or so on and so forth, where you do not have a label for the data. So for example, unsupervised learning could work where you have groups of things, for example, apples, oranges, and bananas, and it is able to sort these out without telling what they are. Because what it then does is tries to find features and similarity of features, and then try to categorize with that. So the answer to your question is yes, but it is using more supervised learning. That's what I would say. Okay.
Yes, got it. Thank you.
Cool.
Yeah.
Thank you. Yes. So I will take Saif. Yeah.
Thank you, Ajit. I think I'm going to go back to earlier question which Shreya asked about, how do we approach a problem and which is the best algorithm to apply? And I guess we could possibly use multiple algorithms and potentially see which works the best. Is that kind of approach which is widely acceptable?
So there are two approaches. The one is I'm going to discuss more examples of algorithms right now with that. So that's one way to look at it. The other way is given a problem which has multiple algorithms, which one to use. Yes. So if there are 5 or 6 different classification algorithms, which one will you use? Yes. And that's the time when you try multiple ones and sort of build up a case using that. So again, we will kind of see that both in discussion and in code. So in about 15 minutes, I'll hand over to Aisha, and Aisha will start talking about regression and classification in code. Well, regression today, not classification. But yeah, so the long answer is that will come over the next few sessions with that. I hope that answers your
Okay, no
question.
problem. Thank
So
you.
yeah, so I will take more questions. We have still more questions here. So Shaurya, yeah.
So basically, sir, thank you, sir, Ajit sir. But I've got one question. Is that basically in the labs we've got chemical problems like hazardous materials like chemicals.
Yeah.
So would there be is there like a robot that that using deep learning thinks that this is dangerous, so will protect the students because in real life I'm a student, so
Yeah.
sometimes it happens because humans makes mistakes,
Yeah.
and teachers can be there by a split second late, so it could be a big problem.
Mhm.
So if there are like any robots that are there any robots that do this,
Okay.
like prevent?
Okay, so there you can split the problem into two parts. The first part is the actual hazard based on the based on the chemicals you are mixing, correct? Yes. So for example, you have some chemicals, you are going to mix them, and the two of them, if they mix, are going to cause a hazard. Yes. And the second part is the intervention by the robot, which is the physical object, yes, which will intervene into something. Yes. Now, the first part could be detected by a number of examples, number of ways. They include vision, computer vision. They include some other sensors which you could have near to that. They include things which could predict your behavior or show where your hand is going, whether it's going near the sort of the bottle, which is risky, that type of stuff. The intervention is a separate problem. The intervention, if it were using a robot, then the word you need to search for is called cobot, C-O-B-O-T, cobot. Instead of the word robot, the word cobot. Cobots are a new category of robots which are designed to work with human beings. So they are not like the industrial robots. They are more smaller. They mostly typically sit on a desktop with you, and they can do things using that. So if you were to sort of frame the problem in this way, that you want definitely a robot to intervene with that, then it would be a desktop robot sitting on your device, and it would intervene with that condition. And that's generally that type of robots. If you Google the word cobot, you'll possibly get something there. Okay,
Yeah. Thank
cool,
you, sir.
thank you. Yeah, so Sonal, yeah.
Thank you. If my question is about some of those videos that you were giving us examples about,
Yeah.
not the GAN ones,
Uh-huh.
but for example, if we have a problem like we have installed surveillance cameras in the neighborhood to detect any, malicious activity happening, and we want to alert the authorities based on that. What I want to ask you is, like, in that case, do we combine a recurrent neural network and a convolutional neural network to analyze those kind of videos? I mean, I understand there could be like multiple levels of things that we need to do, but is it possible to combine those two? Is my question.
Okay, the short answer is yes. And the long answer is that it depends on the modality and the nature of the threat. So for example, if you have, if you by using, so there are two things here. So we haven't talked about recurrent neural networks. So recurrent neural networks typically work with sequences of some kind. Yes, so generally some kind of a time series or a sequence which from which you can make a prediction. And similarly, convolutional neural networks work on images. So yes, you can combine those two, and yes, you can detect a particular behavior and anomaly based on something. So for example, you could say that a person who looks suspicious, maybe he has a hood, or maybe he has some kind of a vehicle which is a concern, is coming in the proximity of something, then that's how you would look at it. Therefore, you would have images and you would have a sequences, and those two combination within that would help you to detect something. So that's how you would look into that. Yeah. So the short answer is yes. Yeah.
Okay,
Okay.
thank you.
Thank you. Yeah. So I'll take John's question and then Santosh's question. So John, a bit of an open-ended question, but in your opinion, could a GAN be a good source of synthetic data or likely to compound bias? So GAN is definitely used for synthetic data. I can tell you that for sure, because we have also used it for certain cases. And the way GANs work with synthetic data is because again, synthetic data is nothing other than understanding a distribution for a particular problem. Yes. So if you have a set of 100 pictures which have something, yes, you have a mountain, for example, each of the 100 pictures, then mathematically that image is a series of numbers, and those numbers have a distribution. Yes. And so if I'm able to understand the distribution behind those numbers, if I put them in a matrix of some kind, I'm then able to say that that's what that pattern looks like. And then I can create similar distributions which would look like mountains to us, but for for a computer, they are just more numbers, which would do that. Now, whether it's a good source of synthetic data, yes, it is definitely. The bias question is, of course, related but not directly connected. So you can introduce bias into many different ways. A GAN is one way to do it. You could say that you have more examples of something, but it's neither here nor there. A GAN can be used to generate, for example, a variety of data sets and therefore reduce bias if you want to sort of see it like that. I hope that answers your question, John, with that. Yeah. So Santosh, yeah.
Yes, sir. So this Babylon app used
Yeah.
by NHS in London,
Yeah.
what is based on AI or?
Yeah, so Babylon is in the UK. Babylon is a company which helps you to diagnose things. And yes, Babylon app is definitely based on AI. It is based on a number of factors where it is able to help you to make a diagnosis about something. And this is generally based on the idea of understanding. I haven't used it, but yes, I believe there is AI involved into that. And because it's certainly trained using, because the thing is it is able to give a diagnosis based on cases, yes, and those cases have been trained using a deep learning machine learning algorithm or something like that. Okay, so the short answer is yes. So Prashant, yeah.
Yeah, thank you, sir. So I have one question, actually, maybe a very basic question. So when we talk about the neural network, so is it something like it is the way to get into the database and find the data that is looking similar, that's what we are looking for. Suppose like we are looking for Russian language to English language. So how the data path or the neural network will transfer? If
So I would not call a neural network like a database, although I can see why you are saying that. I would call a neural network, a trained neural network, like an executable. Yes. So I would say that
Okay.
you have an exe file or something like that. Yes. So I would say that a model is built using an algorithm and data. So you have some data, like Aisha is going to demonstrate to you now. So you're going to build a model, which is the regression model for predicting house prices. So when you
Mhm.
build this model, whether it's a machine learning model or a deep learning model, you have trained your algorithm with some data set. On that, you have effectively a model which functions not like a database. I would call it like an exe. So it has some kind of a program which is running, and then you can ask it a question, it gives you a response, and the structure is not like a database structure, but it's more like pointers. If you think about
Okay.
pointers in C or something like that,
Mhm.
that's how I would, if I were to give you an analogy, that would be my analogy for it.
Okay. Okay.
Cool. Okay.
Yeah. Yeah.
All right.
Yeah.
Thanks.
Yeah. That helps. Thank
Sure.
you.
Yeah. So I think that covers all the questions. There are no more questions on this so far, which is fine because I think I was going to start something else, but it's almost time for Aisha, and Aisha's here as well. So I might as well hand over to Aisha now. Aisha, you there? Yeah,
Hi,
good.
I'm here. Can you
Yes, I
hear
can
me?
hear you. A bit faintly, but yes, I can hear you.
Oh yeah, if it is disturbing, just let me know because I'm using the microphone right now, but I can switch to the computer's microphone.
I can hear you. It's a bit faint, but we can hear you. Yeah, no problem. Yeah.
Okay.
Okay, good. So I'll hand over to you now. I think we have just about come to the right point with that. Again, if you want to, I think we'll do the same sort of thing as we did before, isn't it? We'll explain the problem, we'll give them the code, and we'll give them 15-20 minutes, and then they can come back and ask questions, correct?
Yes. Am I not going through the
Yeah,
basic?
you are going through. Yeah, you are
Okay,
going through.
then
Yeah.
we will give them a time again.
Yeah. Okay, good. Okay. So I'm going to mute myself now and you take over now. Okay. And you should be able to share your screen, I think. Yeah.
Yes, I'm just sharing now. Just let me know if um,
It's
can you share
coming.
the screen?
Uh, I don't see it yet, but maybe it'll come in a minute. Yeah, it's coming. Yeah.
Is it coming?
Yeah.
Okay. I mean, is everybody seeing the screen?
Yes. Yeah. We can
Okay.
see your screen.
And I also shared the notebook code.
Yeah.
Do you want me to share the code again here?
If you want to, it's fine. I did that in the chat, but it is in Slack. I saw it in the morning.
Okay.
So if you want, you can share it here in the chat, or I can
Yeah.
do it for you if you want.
No,
Do you
no,
want me
I'm just
to? Okay.
putting it.
Okay.
So where is the chat here? Oh yeah, here.
Yeah, bottom right. Yeah.
Is that right?
Yeah. We can see it. Yeah. Thanks. Yeah.
Okay. Okay. So last week we have seen the key Python libraries for the machine learning. These were the NumPy, Pandas, Matplotlib, and scikit-learn. And today we are going to use these libraries to create the machine learning model, and we are going to explore the regression problem. And we are building and developing the regression model, and we are training the model, and then we are evaluating the model. And here the following Python libraries we are going to use, as I mentioned, the NumPy for the linear algebra, the Pandas for the data structures and the data analysis tools, and Matplotlib for the plotting functionality, and the scikit-learn for the machine learning algorithms and the machine learning tools. Firstly, we are starting by importing the necessary data packages. Before the importing the packages, let me give you a brief introduction about the dataset. We are using the Boston dataset, and we will also load the dataset. I will talk to you about the more information about the dataset. We are using the Boston dataset. And here we are importing the Pandas, scikit-learn, and we are using the scikit-learn dataset. This is a platform for the small standard datasets. And from this set of datasets, we are loading the Boston dataset. Then we import the pre-processing, the libraries, Matplotlib, NumPy, and the other methods and functions from the scikit-learn, like the train and test split. And in this regression problem, we are using the SVM, support vector machine, and we are importing the support vector regression model. And then we are importing the grid search. Then we are importing the seaborn and the metrics for the regression problem. And the structure, just as a recap for the machine learning workflow. So what we were doing is, firstly, we are defining the problem. To do that, we are looking at the data set, and we are pre-processing the data set. And once the processing is done and our data set is ready for modeling, we are training the model and we are evaluating the performance. So this was the overall the machine learning workflow. So let's start by loading the Boston dataset. And we are saving as a variable Boston. Oh, sorry, I forgot to import this. It will give an error. Yes, we imported the libraries, and next step is the loading the dataset. And if we want to know more about what sort of detail is provided in this dataset, we can call the keys. And here the dataset has data, has target and feature names and description, and we will look at what those are right now. Let's call the description. So here you can see the description about the Boston dataset, Boston house prices dataset. So it has 506 instances, and it has the 13 attributes, and these are the attributes. For example, per capita crime rate by town, or ZN proportion of the residential land zone for the lots of over 20,000 square feet. And here I would like to also mention this, the median value, it will be our target value. So this is the median value of the owner occupied homes in $1,000. And here it also gives an information of the missing attributes values, which is none, and the other information you can find it. Then let's look at what are the features, and let's print out the features. And here, as we can see the attributes here, so here we just printed out the features. And let's look at what is data. So this is an array, and the data information for each of the features. And the next step is we are using the pandas to create a data frame, and we are going to store the data, Boston data, and the Boston features in the data frame. So here are the features and the 506 attributes for each of the features, and we are seeing in the data frame. And this head is just printing out the first 5 rows of the data set for us. And we can see how it looks. And let's look at the target values. So this will be our target values, and we save as a Boston underscore Y. And here, and just one more thing about the Boston data set. Here we can also look at the statistical information, like the count and what is the mean for these features, what are the standard deviation, minimum and the maximum values. For example, if you look at the minimum and maximum values for the features, the minimum is 0.006 and the maximum is 88.97. And here we can see there is a big difference between the minimum and maximum values. So which means that we need to normalize these data. We can easily make it out. And let's try to understand more about the data by plotting. And here we are creating the scatter plot matrix. And this will give us a visualize the pairwise relationship and the correlations between the different values. And let's, here we are creating a plot data function. And here we are calling the function to display the charts. For example, here we are plotting the price distribution histogram. And here I added the histograms tells is the number of the times or the frequency a value occurs within a bin or bucket. So here we can see the frequency of the house prices. If you remember, the prices was our target value, and we can see the distribution also for the target value and the scatter plot for each of the features and the correlation between the features. For example, this is a correlation matrix, and it shows how the features are correlated between each other and from 0 to minus. And here you can see the very much correlated and the rest correlated. And for example, if we look at the 0.9 and this feature RAD and TAX feature is very much correlated in a positive way correlated. And you can look at the other features, how they are correlated between each other. After plotting, the next step is the pre-processing. The reason of the pre-processing is, for example, we may have outliers in the data set, and we need to remove those outliers to make a better predictions. And in this remove outliers function, what we do is we remove if there is any missing values in the data input data. And here we are calling the function, and we are giving the Boston input values and the target values and the feature values, and it returns us a Boston input values and Boston target values. And here it removes the outliers of these, if there is any. And the next step is normalize the data. If you remember, here I talked about the normalization, we have the minimum and maximum values, and we have a big difference. So what we are doing is we are putting all the values in the same range so that our calculation and our prediction will be better. And to learn more about the math behind these scalar functions, you can go to the scikit-learn library and you can read through more about it, how what is the math behind it. So it puts all the values in the same range. And in the pre-processing step, in the pre-processing function, so here we only define the scalar, and it is the normalization function. And here we are calling the normalization function. And what it does is it gets all the input values, and the function calls the normalization data. It puts all the inputs in the same range, and it returns as it saves as x_df. And then the next step is train and test split. We are using the train and test split method. The reason doing is because when we have a train model, we want to test it on the unseen data, and this is why we need to train split the data set into train and test data sets. And here it gets the normalized data input, and it takes the target values, and it splits it splits 0.3 size, which means that 70% of the data set will be the training data set, and the 30% of the data set will be the test data set. And random state is just when you reproduce this, when you recall these methods, it will get the same result for you every time it runs. For example, every time 70% of your training data set will be same and will be same for everyone, so that you will get the same accuracy and same performance result for every time. That's the reason we are just putting any random state number here. And then we are calling our pre-processing data, and it pre-process the data, normalize the data, and it split into the test and train data set. And the next step is we normalize the data, we pre-process the data, and the next step is, and we also split our data into the test and train data set, and let's train our model. And here we are creating another function, train function, and here it takes the training data set, it takes the input values and target values from the trained data set, and it trains the model and it returns the model. And here we are going to call the function, and as a model we are using the SVR. To know more about SVR, again, I would recommend you to go to the scikit-learn library and read through the documentation if you want more about support vector regression model. And so in this case, we are defining the model, and we are calling the train function, we are providing the model, we are providing the X and Y values, and it returns us the trained model. And the next step is evaluating the model. So now we have the trained model, and we need to evaluate the performance of our model on the unseen data set. And here we are creating another function, evaluate function. And these times we are calling the input and the target values from the test data set, so that we will evaluate our model on the test data set. And here we are using the different metrics to calculate the error. So these are the metrics are two metrics, the mean absolute error, mean squared error, and the root mean squared error. So these are the pre-trained, these are the predefined methods. And again, you can find more about in the scikit-learn libraries. For example, let's open and find this out. So here you can read through this documentation for each of the metrics, and you can find out what is the math and how is it done, how is it used. Here in the end, we are getting predicted values, and we have the actual test values, and we are plotting the Y test versus Y prediction values. And here you can see the baseline model performance on the test data set. So these are the predicted prices, and these are the actual prices. And you can see a straight line, not actually straight line. You can still improve on these data set. You can still improve on these data, the model. And these are the result for the R2, for the mean squared error, and for the root mean squared error. And in the last step, we are looking at how to improve the model. So in this exercise, we use the support vector machine. From the support vector machine, we use the support vector regression model. And now we need to look at how I can optimize my model, what kind of parameters I should be using. Or, for example, let's look at this model again. So as you can see, this model takes many parameters. When we were, for example, the kernel, degree, gamma, C values. Let's go back to train value, and I just want to show you. Here, when we defined the model, we did not provide any parameters into the model. So it takes whatever the default values, and we trained based on these default parameters. Now, I'm thinking what kind of parameters I can provide my model, and it gets the better result for me. So to do that, I'm using the grid search function, and I'm building the grid search object. And here again, I'm defining the optimize models function, and I'm giving the X train and Y train. And here I'm giving the parameters like the kernel, linear, and RBF. And as a C parameter, I'm giving the 1 and 10 values. And here I want to see that which will give me a better result to optimize my model. And here I'm calling the grid search. I'm providing my model. I'm giving the parameters, and I'm fitting the model. And it returns the best parameters for us. And let's call the parameters, and let's see what will be the best parameter for my model. So by using grid search, it says to me that use the C, 10 for C, and use RBF for kernel. And based on these best parameters, I'm creating my best model. So I'm defining the best C as C, and I'm defining the best kernel as kernel. And here, again, I'm defining the model, but this time I'm providing the parameters inside. As a kernel, I'm getting the best kernel. As C, I'm getting the best C, which is the C output of the grid search. And again, I'm calling the train function. And what was train function is doing, let's remember. Train function gets the X train and Y train, and it trains the model, and it returns the trained model. So we provided the optimized parameters. We are we are giving the model, and we are providing the inputs and the targets values, and it returns us the trained model. And in the end, we are calling the evaluate function, and it returns the error values for us. And we can see also how the prices and the predicted prices plot is changed. I think it becomes more straight line, and looks like we improved our model by optimizing the parameters. So this was the end of this module, the regression problem. Now we want you to have a look at it, run through it, and if you have any question, ask questions to us. And if you have any question after this, you can also post them on the Slack.
Yeah, so I think thank you very much, Aisha. As you can, as some of you would have already noticed, that there are certain things here towards the end which you definitely wouldn't have heard of at all. So, for example, the hyperparameter tuning and so on and so forth. Those ones we will be covering as we go along. But the key point here is that we want you to run this on your own independently, each step now in the next 30 minutes maybe. And then I think you've got to mute yourself. Maybe Aisha, if you mute yourself.
Yes, just one.
Then, yeah, echo. Yeah, that's fine. Yeah. So what we want to do is spend the next 20 minutes on your own. Any questions you have posted here on the chat, then Aisha and I can come back and address those questions. But what we want you to do is cover as much as you can just by running it. Yes, because we want you to get the experience of running the code and getting used to it. And then you can come back again afterwards in over the week and post more questions on the chat and this on the Slack, sorry. And this way again, we will continue this with that. Okay, so I'll take the 3 questions which are raised now, and then we go from there. Yes, please. So Shreya, yeah.
Yeah, so you have created the linear regression model. So
Yeah.
can we get the equation that for the slope and constant? That equation can we derive from here?
Yes, there is a way to do it, I think, but I'm not sure how. There is because the thing is, you are getting a function. You should be able, but it's a little bit more mathematical with that. So at the moment, remember that what we are trying to do by using the fit function, it is fitting the data to the problem and trying to derive the line which looks like a straight line. And Aisha improved the line using some more changes to the parameter. So yes, there is an equation, but I'm not sure how easy it is to derive it from that. So that's the answer to that.
Okay, so is it like for the prediction of any data? I mean, during the consultation, if it is like if they have come up with some of the data, so that I need to put it in the test data, and then I have to tell them that this is the prediction from
Correct.
this
That's
model.
right. That's right. So
Oh.
what Aisha has done showed you, and you will see it when you run the code again, is that you're splitting the data. The training is what is used for training the model. So if you have maybe hypothetically 1,000 examples, you split it into your your train data set and your test data set with that. So you train it using that, and then you see the evaluation, and you show it. The test is what you haven't shown it before. That's the point.
Okay, this is the regression problem that you have, I mean, that you have shown as in general, but there are number of regression, means like logistic regression or something multinomial. So this type of regression will also fall into this kind of coding, or is it like the separate one we have to go ahead?
The general approach is the same. The model will be different. So where I showed you import that particular thing, I think you'll have to import logistic regression or whatever other forms of regression you want to do, and then show it like that. But the general flow of it is still the same.
And I mean, this is like which model which we have to use, that we have to consider it at the, I mean, by looking at the data, right?
Correct, because you are trying to predict the number here. Yeah.
Okay. Okay. Fine. Thank you.
Yeah. Sure. Thanks. Yeah. Yeah, that's fine. Farid, that is not an error. It shows it's a warning. It says it's deprecated, but it is not an error. It will be removed in subsequent versions of it. So this is what I mean by just what we want you to do over the next 15-20 minutes is to run it as much as you can and try to understand as many steps as you can with that. So those are not errors with that. Yeah. So thank you, Saif, for that. Yeah, this is good. So like we said, with the next 15-20 minutes, just try it out. And then again, post the questions here, because then again, our goal is to make sure that you are running it as much as you can here with that. So Varun, yes, please. Yeah.
Yeah. So the random state is something which was mentioned, that it actually makes static the train test split data, right? But if random state is not mentioned, then every time we run the code, it's going to be a different combination of train and test, and we're going to get different set of results for the regression model, right? But then wouldn't that actually enable us to, take the average of all those results and then make a more accurate result by
No,
not
no,
specifying
no,
random
that's
state?
not how random seed works. So have a look at the documentation with that, because I think you already have some background with these things. I think you can easily pick it up from the documentation of how the random seed works with that. So it's definitely not taking an average with that. Yeah, cool. Okay, perfect. So
Okay.
Santosh, yeah.
Yeah, hi sir. So I'm still trying to come out of the conventional coding thing. Yeah, so probably we start with some kind of a flow chart so that it describes the thought process.
Sorry, I can't hear you properly.
Yeah, no,
Yeah.
I can hear you. It's fine, it's fine. Thanks, Ashi. Yeah, so no, the flow chart, if you want, you can draw it, but this is not about a flow chart as such. This is more a sequence of steps you can run. So at the moment, just run those steps and you will get something. But this is not a flow chart, as in there is no conditions within that.
Okay,
For that.
okay,
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 thanks. Yeah, yeah. So
okay.
Nitin,
So the steps are like load the data set and plot the graphs and
yeah,
process.
that's right.
The
That's
steps
right.
which
Those are the
I just,
steps with
yeah,
that.
okay.
Correct. Yeah, yeah.
Okay, okay. So
So
following the steps is important, and we are trying to solve here a regression kind of a problem, but
yeah.
steps will be different for different kind of a problem.
Yeah, very, very good.
Okay,
Yeah.
thank you.
So correct. Yes. So Nitin, yes. So thank you for the posting about random start. So that's the same with Varun as well. That's a question from Varun. Yeah. So Priyanjan, course recommendation for Python. Yeah, that we can come back to you afterwards with that, because I just want you guys to run the code for next 20 minutes. I would suggest you run the code with that, because we really want you to see and come back with specific questions regarding the code with that. Okay, so Aishay, we will let them run for 20 minutes. Yes.
Yes, I'm just waiting for it.
Yeah. So we won't let them post the questions in the chat.
Mm-hmm.
Yes, this is what I'm
Yes.
suggesting, and then we will respond to the questions after 20 minutes, so that I want them to keep on running it as much as they can, because at least if they run the whole code end to end, at least, because there is nothing, it's literally pressing the buttons with that, correct? But hopefully they should be able to understand it as they run it with it as well. We'll give you 20 minutes for now to run the code. Any questions you post here, and again, you can post the same questions over the week as well. Okay. All right. So Aisha, we will mute ourselves and we'll be back after 20 minutes. Okay.
Yeah.
Okay. Hi, Shay, can we discuss the questions now? Or we got 15 minutes more, isn't it?
Yes, we left 15 minutes more.
You're muted, I think. Are you? Yeah.
Can you hear
Or
me?
am I got, oh, sorry. Yeah, sorry, it's my problem. Yeah, sorry, please go on, Aisha. Yeah. Can we
Yes,
start it?
we
Okay.
can start. Yeah.
Okay, so we'll try to take as many questions as we can. I've cross-posted this chat on the question for tutors so that we can track the questions afterwards in case we don't get that. Okay, Shreya, you've raised your hand. Yeah.
Yes, actually, sir, regression we are using that is okay, but can you give us a little bit examples that how deeply and I mean the types of regressions what we are having and how what are the examples related to it so that we can understand which kind of regression we can use for which problems?
Okay, if you post this on the question for tutors, we can answer it there. Mainly because I want to spend the next 15 minutes on the code with that,
Okay.
as many questions with the code. Okay, Santosh, yes, yeah.
Yeah, two questions. One is, see, outlier would depend on whether in the first place your data set is correct or not, right? Because suppose you have chosen a data set which itself is an outlier, but whereas the meaningful values are somewhere else. So uh, you got my question, what I mean. The choosing right data set is important to find out the outlier. Is that correct?
Outlier is a function of how the data point relates to the other bits of the data. So so some data sets will have more outliers, so yes, I mean that is the case, but the outlier is not a function of the problem. The outlier is a function of the data. That's all I want to say, but I think we are saying the same thing. Cool.
Yeah, I
Okay.
think got it. I got
Yeah,
it. And the
yeah.
second thing is, probably if you are covering this parameter
Hyperparameter, yes, we are.
finding,
Yeah,
yeah, if
definitely.
you are
Yeah, it's
covering that afterwards, that
yeah,
is
yeah, yeah. We definitely we are.
that's
That's
clear.
what I said
Oh,
right in the beginning. I said that we definitely won't be able to cover that now. Yeah,
all
we,
right.
we, we we definitely haven't covered it so far. Yes. So I think so. Farid, can you explain syntax of? Yeah, that's fine. Thank you. Oh, sorry. Yeah, thank you. Yes, with that.
Thank you.
So I'm just going to, before I come to Santosh's question, who's raised your hand, I'm just going to look at the. Can you explain syntax? Not familiar with the print, the features, data sets, the features. Yeah, that's just printing the features with that. So this is what is the Boston? There's a target median value. Yes, that's good. Ignore okay, that's fine. Aisha has printed that. That's is good. So it recurs the following. Okay, what are these keys defined? Where are these keys defined? So they are defined in the data set within that. And I think that again, if you look at the E keys one, that's how you get that, but are typically defined in the data. See that this particular data set is preloaded into scikit-learn. Yes, so this is important, that this is not a data set which we have loaded. And so these data sets are what are called preloaded already into the system so that we can use them for learning. And that's why they have some things defined for them. And that's what this is within that. So in the data structure, I should answer that. Good. So the Boston housing pricing here, the ethical problem, you can, yeah, that's fine. That we know that, and that's a standard thing. We know what the ethical problem is. That's been in the industry for many years. With that, I'm glad they're getting rid of the data set, but at the moment it still works. I'm sure they'll remove it going forward. Even in Oxford, we use this data set, but we remove some features from it. And that's why I think this is a problem with that. And I totally agree with what they're doing. It's high time they remove that data set from there. But it is a useful data set, and you can still use it without the features, which is what we try to do. Some of the features, yeah. So is the distribution linear? Is the bin distribution linear? Um, I don't know what that question means, but maybe we'll come back to it from Farid. Yeah. Thanks. When the data was loaded in the data set, it had headings. Can you please walk through how the data set is defined based on the raw data? This data set, so Santosh, this easily you can Google it. It's called the Boston housing data set. It is also defined in the structure itself. Within that, it was also defined in my slides. So if you look at my slides, you will see that there was a column there which described every feature and what the value of the feature, what the meaning of the feature was. So it is there in my slide. So this is Santosh's question.
I
What?
get that. I get that.
Yeah.
Sorry.
The question is like, see, like for example, you have the headings, right? You have 10 columns, you have the 10 headings. Question is, from those 10 headings, which are defined as a keys? That's one of the property, right? So that's what I was trying to understand, how these different attributes, like the key attributes, are defined.
That depends on on how you're defining that's the structure of it. So in this case, it was already defined for us because it's a pre-existing data set. So typically a key would define how you're trying to define what is the unique value within that. Yes. So for us, realistically, what we are trying to do is it is not more about unique values or keys. It is more about whether that particular row is able to define the target variable. So that's the answer to that. But I hope that
Okay.
that clarifies that. With that, what is the in place command? So drop NA. So drop NA, I think, is dropping the null values from there. Ashwini, looking at the code, it's in there. Most of the AI functionality has been provided by the code, so it is a challenge in creating the training data set, the best trainer. So this is Ashwini's question. Um, so is the challenge in creating the training data to best train the AI model? So Ashwini, in this case, there is no, so what we are trying to get you to do is to run the code as it is, to understand the code. So typically when we use something like this, what we do is, and in fact, this is what we will do later on as well. We will give you some exercises to do, which will involve you modifying the code to do something else. So at the moment, what we are trying to do is get you guys to just look at the code, because then if you run it step by step, you can see much of what I've been talking about. For example, test data set, training data set, feature engineering, outliers, that type of stuff. You can see all of that happening with real data and with graphical outputs, and you change the parameters like Aisha did and improve the algorithm, that type of stuff. So we want you to get used to these steps, but there is nothing you are going to change at the moment. That will come later on with that. So this is Ashwini's question. Yeah. So Vaishali, yes, Aisha answered that. Heat map confusion matrix. Okay, drop any, Aisha answered that. Um, it's not a confusion matrix. The yeah, no, confusion matrix is different, John. Heat map is just a correlation, basically correlation between variables. That's it. Why are the outliers removed? Is it hard to just get a better fit for the model? The handling of outliers is a different thing. Some people remove them, some people include them, some people try to explain them, and so on and so forth. So like I told you, in the sort of medical examples I gave, outliers are not ignored, because outliers could be dangerous, they could be showing you something different. But in this case, maybe it is just a random observation. We are just talking house prices here. Yes, so maybe it was an outlier in terms of somebody entered something wrong, something like that. So it depends on your problem how you handle outliers. So what is the difference between TensorFlow and SVR? So Shreya, so SVR is an algorithm. TensorFlow is a library which is TensorFlow is a effectively a set of Python libraries. SVR is an implementation of an algorithm called support vector regression within that. So similarly, when you use another algorithm, logistic regression, you will use another package from there. So SPR is a package and TensorFlow is a library. Okay. So Vaishali, thanks. Pratik, what are we trying to do with the scale numeric functions? We are trying to normalize the data within that. That's what Aisha, maybe you can answer that as well with that. Oh yeah, you have answered it. Yeah, normalization. Correct. Yeah, that's good. Yeah, because Aisha answered that. That's good. So can describe, tell me how far my data point is. No, describe is just understanding the data structure. It doesn't tell you how far something is from that within there. So describe it just like a description of your data structure. It doesn't tell you more than that. So Aisha has answered that. For Pratik, train fits normalized data to a pilot, to a plot. Sorry, plot. The train is when you train the algorithm with the data, so it fits the normalized data. Well, a plot is just a representation of it, so it fits the algorithm to the data, the training data. So it is, I would say that a plot just shows you how effectively things fit within that. So built-in data sets within that. Paul,
So,
could you? Yeah,
So,
sorry.
my question was, so what are we trying to do with when we see this graph or when we train it? Uh, what answer we are looking?
So when we train something, I don't know which graph you're talking about. Maybe Aisha, you can answer this because I don't know which graph it is.
Yes. Which graph are you talking? I
So the
cannot
last
see
one,
my
last
screen.
one,
Yep.
last one. So
Uh,
the
in the evaluate the model section, you mean? I also
yes. So
share my
the 35th step number 35th, 34. Press.
Uh, is this one? Are you talking the graph? Can you see my
Yes,
screen?
yes,
Yeah.
yes. That is the one. Yes,
Um, so your question is, what is this graph? Is that right?
yes.
Okay. So in the this is coming from the purpose of the evaluation actually. So what we are doing is when we predict the when we train the model, we have a train model and we need to find out how our model is acting on the test data set. And then we are also getting the predicted values. So when we call here, um, just 1 minute. Yes. So we are getting the train model and then we are providing the inputs, we're providing the targets, actual inputs, actual targets, and we are predicting how the actual inputs will act on the trained data set and it will predict some values. And we are recording these as a predicted y, predicted target values. And so and also we are saving as y underscore pred. So in the end of this model, in the end of this function, we have the actual test values and predicted test values. And here we are comparing it like, for example, if the actual is 10 and what is the equivalent for the predicted values? Sorry, let me just make sure. Uh, sorry. Yeah, it is just plotting of where are the actual target values and where are the predicted values. And if it is giving us a straight line, so it will show us how much our model is fit actually. If it is completely straight, which means that our actual uh, target values and our predicted test values is completely fit and our model is very much fit. And if we are seeing this, for example, if we're seeing dots here, which means that we need to still optimize our model. We need to still improve our model. So it is just showing us how the actual and the test values are close to each other.
Okay. So, do we have a time for a question, or should I post it on the chat?
Yeah, you can post it in the chat. We can answer it better in the chat some cases, but also run it with that, and then you might understand it more as well. But yes, we'll post it in the chat, and we can answer it from there. Cool. Okay.
Okay. Okay.
Perfect.
Cool.
Thanks. Yeah.
Cool. Thank you.
So thank you, Aisha, for that. So Dr. Gore, how can we ask the model on the new data entry to predict the price? Is it covered in the next session? How do we select the parameters and improvisation? Is it, yeah, the parameters, we will come back with that. How do you ask the new entry? Um, that is just when you run it, isn't it, in the end, Aisha, with that? I don't remember.
Sorry, Ajit, I just missed
So
the
I'm
question.
no, so
What
I'm
is
missing
the
the
question?
question.
What
Looking
do
at
you
this question
think of?
here in the chat. So when you have a new value to predict it, so this is when you run the model and you pass it a parameter for a new value with that. Okay, let us come back to this. I think because it's quite late, I can't
Uh,
sort of answer
yeah,
that.
just post this question and let's have a look at it
Yeah, yeah, let's do that. Yes,
on the
so that's
detail.
good. Thank you very much. With this, so what I'll do is I'll copy the chat again. I posted the chat just with that, and I have one particular something. Let me just put this in the chat. So what I would suggest, if you can give us some feedback about how you like the course and things like this, or if whether we should change something, let us know. If you put it in the Slack or send me a message on Slack, and then if we can use it afterwards, we will let you know. But mainly because we haven't done this before and this is the mixed group, so I think that we are sort of yeah. So again, I'll just trying to make this thing. So if you just give us any feedback on this, I think that's good. If you post it on Slack, or if you in the general section, or if you let us know by message, I think that is good. And then we can kind of go from there. Okay, thank you, Aisha, very much. So I think we've done what we wanted to do today. We'll look at the questions, we'll come back on that. And I have posted the questions again on the chat as well, and we'll answer them on the chat with that. Okay, so all looks good. Let me try to get back to the screen here. Yeah, this is fine here. All looks good. I should want to add anything.
No, Ajit, thank you very much. And
Okay.
please ask any questions. And I'm already getting some question, and I will look at them.
Yeah, yeah. So post a question in the question for tutors. And Saif, what you asked with what do we do with that? So what we want you to do is just go through the code and post any questions with that. So we are not asking you to modify the code or anything like that. Just literally run through the code, find out step by step or whether you understand that. Many of the things you can Google them, or you can find out the parameter values and things like that quite easily. And some cases you won't be able to. But the point about this is that by running the code in this way, step by step, you actually manifest something in real life, meaning that you see something real from a real data set with a real problem, with real values, with real accuracy. You improve the accuracy and so on and so forth. And meanwhile, as you have questions, we'll sort them out and then we will kind of go from there with that. Very good. Okay, so
Should we post them on Slack?
We have in the Slack we have a channel called questions for tutors. So that's the one channel we always use for question for tutors. So if you go to Slack, you will see that there's a channel for that. That's where I also posted the conversation. This I just copied and pasted this thing, and I posted it in the questions for tutors there as well.
Yes, Ajit, can you tag that channel, because last time, like resources, I'm not able to see that channel. So if you tag that, then we can add
Okay,
it.
I will do this. I don't know why that happens. So
I think
questions.
you can probably go to the add channels over there, look at what channels are available, and join them directly.
Yeah, this is the thing. I don't know why this. Okay, so I've tagged it in general now, so everybody will be able to see it. Questions for tutors with
Pasted
that.
it in the chat. Let's try that.
Yeah, yeah. So if you
Yes,
go to
yes.
general, I've just tagged it question for tutors. So you will be able to see it from there instantly, and just click on that, and that will work with that. And that's where we are using all the questions with that. I just wonder if I can add everybody to this. I don't know how I can do this. I'm not so used to Slack anymore as I used to before. Um, anyway, good. So thank you very much. So please give us some feedback if you want to. By personal message, direct message on Slack is fine. Anything we can, if we want to use it externally, we will of course ask you. And yes, all is good. Thank you very much. Thank you, Varun, for posting that. So Aisha, do you want to add anything? Yes, good.
Yeah, all good, Ajit.
Good.
Thanks for everyone for joining, and
Yeah.
have a good day to
Good.
everyone.
Thank you. And
Thank
again,
you.
like I said, we will keep on, yeah,
Bye.
we will try to keep it slow, meaning that we will try to go through
Yeah,
the questions, try to spend interactivity and so on and
yeah.
so forth, because over time you will learn this, even if you spend 8 weeks literally with this one, without kind of just going through what is happening, you after some time it all starts to make sense. Although it's not a easy subject, we know that, but I think that that will be useful. Thank you very much. And yeah, feel free to send me some messages by Slack if you want to, just quick feedback, because like I said, I have not done it in this format before. And Aisha and I, of course, we are both teaching at Oxford, so we know how the groups work, but we have not used a diverse group like this in this way. Very good. Thank you again. Thank you, Asha, as well. Okay. All right.
Thank you.
Thank you.
Thank you.
Thank
Thank
you.
you.
Bye.
Bye. Bye. Bye.